Hello everyone, I'm Sagarika Chian, currently pursuing my BE in Computer Science from Sri Venkateswara College of Engineering. Today, I'm here to speak about IoT-based water quality monitoring system and evaluation under the guidance of Professor Rakshita KS. So the table of contents are abstract, introduction, literature survey, methodology, implementation, results and discussion, conclusion, and references. Abstract. An extreme pH level of the swimming pool water can cause a serious reaction to eye and skin of the users. The existing method for monitoring the water pH level is not efficient enough to monitor the quality of the water because all the processes need to be executed manually. This paper discusses the proposed smart water quality monitoring system design. The evaluation of the factors influencing pH value and temperature of swimming pool using DOE and ANOVA statistical tools. The experimental findings reveal that time of day, pool volume, and their interaction factors do not influence the pH value. However, time of day have an effect on the water temperature of the swimming pool. Introduction. The IoT consists of physical devices that are interconnected with each other, which exchange data and interacts with each other beyond machine-to-machine communication via the internet. This evolution has attracted the interest and attention of many industries to be a part of the IoT, such as information, transportation, agriculture, healthcare, and manufacturing industries. The real-time measurements and reporting systems are important for the implementation of flexible work strategies as they provide timely information for the decision process for the user to respond accordingly to the current situation. Remote monitoring of water quality is necessary to identify any changes in water quality parameters in real time. The main process involved in this is collection, measurement, and analysis of water samples. As we all know, water is not only used for domestic purposes but also in agriculture, for aquatic sports such as swimming and water polo, which involves the consistency of good water. pH level is used to determine the quality of the pool water based on the amount of chlorine. pH is one of the parameters that should be monitored most frequently in all pool types. A pH below 7.0 is considered acidic. 7.0 is neutral, while a pH above 7.0 up to 14.0 are considered bases. Water maintenance and pH control are important processes because if there are small changes in the pH value on the water, it will affect the quality of the water. In the conventional method, litmus paper is used to measure the pH level by dipping it into the sample of swimming pool water. Literature survey. The first one is water quality monitoring and waste management using IoT. In this paper, it tells us how the industrial sewage water quality can be monitored using IoT. However, this paper has a drawback, that is, it requires more time. We can overcome this by increasing the speed by using sensors like pH sensor, temperature sensor, and cloud, etc. The second paper is Cloud Assisted Wastewater Management System for Smart Cities. This paper tells us how cloud can be used to monitor the water quality. There's also a drawback in this, that is cloud process is slow. We can overcome this by increasing the speed of internet. The process of the cloud will also be increased. Application of NB IoT technology in city open water monitoring. In this paper, we present an IPv6 network connected IoT design for real-time water flow metering and quality monitoring. This approach was not satisfied. We can overcome this by using IP address of that person through cloud. We can send the results or test data to personal computer or mobile phones. The fourth system is wastewater management for smart cities. This paper presents the need for wastewater treatment and also gives the brief description of various stages of wastewater treatment. This paper also has a drawback, that is, advanced technologies were not used in the system. We can overcome this by using advanced technologies such as Arduino board, sensors, actuators, and cloud. The fifth one is a low-cost system for real-time water quality monitoring and controlling using IoT. In this paper, we got an idea of how the water quality can be monitored in real time. Drawback of this paper is it involves a lot of manual work. We can also overcome this by using sensors, Arduino board, which also reduces the manual work which needs to be done. The last system which was taken into consideration was an IoT based WPN enabled experiment for water management. In this paper, we present an IPv6 network connected IoT design for real time water quality metering and quality monitoring. This paper has a drawback, which is they cannot directly communicate with internet based devices and web servers. Okay, in order to overcome this, we need to use an IoT model which can directly communicate with internet based devices and servers or browsers. Methodology: Smart Water Quality Monitoring System. In the conventional method, the maintenance staff of the aquatic center used to monitor the pH value of the swimming pools manually. In this method, however, the staff will be able to monitor the pH value in real time using their mobile phones or a personal computer. To regulate the pH level of the water pool, water pump 1 and pump 2 are embedded into the system for pumping acidic and alkaline solutions respectively. The proposed system enables the operation management to trace the data and do analysis for all the problem occurred so that the problems will not occur in the future. So this is the conceptual overview of the smart water quality management system. As we can see, we have a swimming pool here, and the swimming pool contains pH sensors and temperature sensor. This also contains pump 1 and pump 2, which are embedded with alkaline and acidic solutions respectively, and also an LCD display. And this unit is connected to an IoT cloud, and we can also see mobile phones and personal computer in which the pH level is displayed, and staff can monitor the pH level of the swimming pool using their mobile phones or their personal computer. In this system, we're going to use Node MCU. Node MCU V3 is a small size processing unit and inbuilt ESP8266. With an advanced API, Node MCU provides advanced hardware I/O APIs which accelerate the configuration and manipulation of the hardware. The built-in Wi-Fi module ESP8266 is integrated on board. This is an advantage for the system because no other external Wi-Fi module is needed for an internet connection. Second one is pH sensor. The selected analog pH sensor has built-in LEDs to indicate its power status. The BNC connector and the interface of the pH 2.0 sensor for communication with processing unit. Another sensor which we are going to use is temperature sensor. The temperature sensor selected for this project is DS18B20. It is a digital thermometer that provides 9-bit to 12-bit Celsius temperature measurements. This sensor only needs one wire which will be the main data line for transmitting temperature reading from the sensor to the processing unit. One sensor contains 64-bit of serial code, which makes an advantage for the user to use multiple DS18B20 on the same data wire. IoT platform. Monitoring data is uploaded into the IoT cloud via UBI.apps. Generally, the data from the sensor is converted into information that matters for mission-to-mission interaction. UBI dots processes the data and shows the data on the dashboard where the user can access the data using their mobile phone or their personal computer. The real-time data collected from sensors can be viewed and monitored from this dashboard. The data is presented in graphical charts to ease the analysis to the user. As we can see the UB Dots website dashboard. Here we can see the temperature and also the meter and also the graphs, the charts provided so that the user can easily analyze the data and take necessary action. So the implementation of the system, the sensors provide data to the processing unit every 5 minutes. There are three conditions for the pH level, which is normal condition, acidic condition, and alkaline condition. For condition in which it is normal condition, the pH value that needs to meet this condition is between 7.20 and 7.80. Second condition, which is acidic, the pH value is below 7.20, and lastly, the third condition, which is the pH value higher than 7.80, indicating it is alkaline water. The user also will get a notification via Telegram apps every time there is a changes to the pH level as shown in the flow chart. For the second and third condition, which is too acidic and too alkaline, the system will trigger pump for pumping solution to stabilize the pH value until the pH change to normal level. User can access Smart Water Quality Management System tracking system to monitor the current condition of swimming pools and take necessary action. The system continuously monitors the temperature and pH value of swimming pool water in real time. This section is focusing on finding significant factors that influences the pH value and temperature based on design of experiment DOE approach. The DOE is considered as an effective tool to perform robust experiment and identify influential factors to the pH level. The factors that were investigated in this experiment are tabulated in table 1. There are three levels for each of the factors, and all of the data are replicated 2 times to increase the chances of detecting significant effects from the identified factors. So the factors are time of the day and pool volume, and level 1 and level 2 and level 3 are used. So time of the day is morning, afternoon and evening, and the pool volume in meter cube is 300, 400, 2250 respectively. Here is a table for the factorial design calculation as shown in table 2. The response variable of the experiment is the pH value and the temperature that was carried out at the Sabarang Jaya swimming pool. All the data are collected following the run order to get accurate data from the swimming pool. As we can see, this table consists of STD order, run order, time of the day, and also the pool volume, and pH and temperature are the response variable. So during evening the pH is 7.20 and the temperature is 30.30. So accordingly this table gives us the factorial design. So this is the architecture or workflow of this system. Initially we start and establish the connection between processing unit and network. Then we move on to read the temperature value, and this temperature value is displayed on LCD, and then we upload this data on the cloud. Next we move on to check whether the pH is normal, acidic or alkaline. If the pH is normal, then if it is yes, then we delay. If it is no, we check whether the pH is acidic. If it is yes, then we send notification to user and activate pump 1 until pH is normal. If it is a no, then we check whether the pH is alkaline. If it is alkaline, then we send notification to user and activate pump 2 until pH is normal, because pump 2 consists of alkaline solutions and pump 1 consists of acidic solutions. Results and discussion. We are using a two-way ANOVA of pH value. The data of the pH value and temperature were analyzed using the Minitab 16 software, and two-way ANOVA are chosen to run the statistical analysis. Here in a two-way ANOVA of pH value, table 3 shows the calculated P value for the time of day is higher than the significance value, which is 0.057. Thus, there is an insufficient evidence to reject the null hypothesis. It can be concluded that the time of the day did not affect the reading of pH value. The p-value for both pool volume and interaction are 0.67 and 0.221 respectively. Both values are higher than 0.05, which makes each null hypothesis H0V and H0VT are failed to reject. Both the pool volume and time of the day as their interaction factors do not affect the pH value. The p-value for both pool volume and interaction are 0.67 and 0.221 respectively. Both values are higher than 0.05, which makes each null hypothesis fail to reject. Therefore, both the pool volume and time of day as their interaction factors do not affect the pH value. In the figure 4 shows the main effects plot for the pH. So these are the things which matter for the pH value. There is a steeper slope between the morning and afternoon, which shows that time of day influences the changes to the pH value. For the pool volume, there are steeper slope between the 300 and 400, also from 400 to 2250 volume. This slope shows that there is an effect between the pool volume to the pH value, but not really significant. As we can see in the table 4, the calculated p-value for the time of day is 0.038, which is lower than 0.05. Thus, there is sufficient evidence to reject the null hypothesis. Therefore, the time of the day does affect the reading of the pH value. The p-value for both pole volume is 0.562, which makes its null hypothesis fail to reject. For interaction, which is this, a column, p into 0.02 value is 0.451, which is higher than 0.05, and the null hypothesis is also failed to reject. Thus, both the pool volume and interaction did not affect the temperature, whereas the time of the day did. Figure 5 shows main effects plot for temperature. There's a steeper slope between morning and afternoon and between afternoon and evening. This shape of slope shows that time of day does give significant impact to the temperature. And when it comes to pool volume, there's a steeper slope between 300 to 400 from the 400 to 2250 volume. This slope shows that there is an effect between the pool volume to the temperature, but not really significant. Conclusion: it has been clearly observed that the system is capable to automatically update the current status of water quality of the pool via IoT platform and make an adjustment to the pH level. This smart water quality management system is also capable to provide real-time monitoring and requires less operational maintenance. Based on a statistical analysis that was conducted, time of day, pool volume, and the interaction factors do not influence the reading of pH value, while for the temperature, the time of day factor does influence the temperature condition. References: we have considered around 10 papers for this topic, and these are those 10 papers. Thank you.